So we were integrating 1 over x plus square root 1 minus x square, and this is where we finished last time. We had negative times the integral of sine 2 theta over 2 cos 2 theta minus the integral of 1 over 2 minus the integral of 1 over 2 cos 2 theta. So we will find the integral of all of these three values, and then we'll be able to find or to get the final answer for uh, our required integral. So we'll be integrating this integral firstly 1 over 2 cos 2 theta, and this 1 over 2 can be moved outside the integral. So I have moved this integral outside, move this value outside the integral, and now we get the integral of 1 over cos 2 theta d theta, and 1 over cos is basically secant. So here we have cos 2 theta, so it will be secant 2 theta, and we are integrating this with respect to theta. So I have written secant 2 theta in the form of this fraction. And why am I writing this secant 2 theta in the form of this fraction? This will be clear in a few moments. So I have multiplied secant 2 theta with 2 and secant 2 theta plus tan 2 theta, and I have also divided secant 2 theta by the same thing, 2 and secant 2 theta plus tan 2 theta. So basically the logic remains the same as it's in the case of secant theta. In the case of secant theta, we multiply that by secant theta plus tan theta and also divided by the same thing. Here we multiply it with 2 and secant 2 theta plus tan 2 theta and multiply it with the same thing. And why do we multiply secant 2 theta with 2 and secant 2 theta plus tan 2 theta? We'll see. So it has a reason basically. So when 2 secant 2 theta is multiplied with secant 2 theta, it becomes 2 secant square 2 theta plus 2 secant 2 theta tan 2 theta. And in the denominator, we have 2 times secant 2 theta plus tan 2 theta. So I'm writing secant 2 theta as this thing. So I'm putting this value in the place of secant 2 theta in the integral. So it becomes 2 secant square 2 theta plus 2 secant 2 theta tan 2 theta over 2 times secant 2 theta plus tan 2 theta. So I have written this whole thing in place of secant 2 theta because this whole thing is equal to basically secant 2 theta. So this 2 can be moved outside the integral, so it becomes 1 over 2 times 2, and inside the integral we have 2 secant square 2 theta plus 2 secant 2 theta tan 2 theta over secant 2 theta plus tan 2 theta. So when we look at this fraction, we notice this thing that the expression which is written in the denominator, its derivative is written in the numerator because tan has the derivative of secant square, but that is in the case of tan theta. Here we don't have tan theta, it's tan 2 theta. So firstly we need to take the derivative of tan, and then we also need to take the derivative of 2 theta with respect to theta. So this becomes secant square 2 theta, tan 2 theta has the derivative secant square 2 theta, and further we take the derivative of 2 theta, which is 2. So it becomes 2 secant square 2 theta. This is the final derivative of tan 2 theta. Similarly, secant 2 theta has the derivative secant 2 theta tan 2 theta, just like secant theta has the derivative secant theta tan theta. But in the case of secant theta, when we take the derivative of theta with respect to theta, it becomes 1. So we don't need to write that. But here we don't have theta, we have 2 theta, secant 2 theta. So we need to take the derivative of this argument 2 theta with respect to theta, which is not 1, which is 2. So we need to write that. So both of these terms have their derivatives written in the numerator. So this whole expression has its derivative written in the numerator. So whenever this is the case, that the derivative of the denominator is written in the numerator, it has basically the antiderivative equal to natural log of, or any log. It doesn't matter whether we take, which base do we take. So I'm writing it in the form of natural log. So natural log of this denominator. So natural log of absolute of denominator. So natural log of absolute of secant 2 theta plus tan 2 theta. This will be the derivative, antiderivative of this thing. And outside there 1 over 4 was written, so 1 over 4 times natural log of absolute of this thing. So this is our first value, or first integral, which we needed to find in order to find this whole value. So we have found the value of this integral. Next we have this 1 over 2. So 1 over 2 can be moved outside the integral of integral. So it will become 1 over 2 integral of 1. And when we take the antiderivative of 1, basically the question which we are asking is that which expression has the derivative equal to 1. And remember, we are integrating this with respect to theta, so the variable is theta. So there needs to be a function of theta, or an expression involving theta, which has the derivative equal to 1, and that expression is just theta. When we take the derivative of theta with respect to theta, the derivative is simply 1. So the antiderivative will be theta. So 1 over 2 theta will be the antiderivative. The third integral which we needed to find the value of is sine 2 theta over 2 cos 2 theta. And 1 over 2 can be moved outside, so I have written it outside the integral. Inside we have sine 2 theta over cos 2 theta. And cos 2 theta, here this situation can be like the one in the first integral, because cos 2 theta, its derivative is written is in the form of sine 2 theta, but it is not exactly sine 2 theta. So we need to make some changes to this expression. So what is the derivative of cos 2 theta? When we take the derivative of cos 2 theta with respect to theta, it becomes, as in the case of cos theta, its derivative is minus sine theta. Here we don't have cos theta, it's cos 2 theta. So its derivative will be minus sine 2 theta, and further we'll take the derivative of this 2 theta with respect to theta, that is simply 2. So the derivative is minus 2 sine 2 theta. So in order for us to use use that form of the antiderivative, in which the derivative is written in the derivative of the denominator is written in the numerator, we need to make this numerator equal to the derivative of cos 2 theta. So we need to make multiply our numerator with minus 2, because minus 2 is missing in the numerator. So if we are multiplying with minus 2, we also need to divide it by minus 2, so that it doesn't have a net effect. So minus 2 is divided, minus 2 is multiplied. So now outside we have 1 over minus 4, which will be written as minus 1 by 4, or can be written as minus 2 sine 2 theta over cos 2 theta. Now we have the perfect form. The derivative of the denominator is written in the numerator. So we can write this as the antiderivative of this expression is simply natural log of absolute of the denominator, which is cos 2 theta. So this is the final antiderivative of this expression. So our required integral had all of these integrals in it. So we just need to now, we just now need to plug in the values of these integrals. So this will become negative times negative 1 over 4 natural log of absolute of cos 2 theta minus 1 over 2 theta minus 1 over 4 natural log of secant absolute of secant 2 theta plus tan 2 theta and absolute and bracket close. So this negative is being multiplied with all of these terms, and all of these terms have negative signs, so these terms will become positive. So this will become 1 over 4 natural log of absolute of cos 2 theta plus 1 over 2 theta plus 1 over 4 natural log of absolute of secant 2 theta plus tan 2 theta. And this is not the final answer because our question was in terms of x, and this is basically in terms of theta. So the last step would be to change these expressions involving theta in the form of expressions which are in the form which involve x. So we used a trigonometric substitution sine theta is equal to x, which can be written in the form of a fraction x over 1. And sine theta is basically, we know that it is perpendicular over hypotenuse, it's a ratio. So we'll draw a right angle triangle and evaluate the third side of this triangle. Perpendicular is x, hypotenuse is 1, and the third side is base. So we will use Pythagoras theorem to calculate the value of that third side. So hypotenuse squared is equal to base squared plus perpendicular squared, and we need to find the value of base from this equation. So base square is equal to hypotenuse square minus perpendicular squared, and base squared is equal to hypotenuse was just simply 1, so 1 squared, which is 1, minus perpendicular is x, so x squared is x squared. So we want base from this equation, and we have base squared, so we'll take the square root. When we take the square root, we get base is equal to square root of 1 minus x square. And why did we need this side of the triangle? Because the expressions which we have in our the final value of the integral, those expressions need the evaluation of cos theta as well, and cos theta is base over hypotenuse, so we needed base. So base is this square root 1 minus x square, and hypotenuse is 1, so it doesn't matter whether we write it or not. So cos theta is simply square root of 1 minus x square. So now we will put these values or use these values in finding the final value of our integral. So 1 over 4 natural log of, here we had cos 2 theta, and cos 2 theta has basically a formula cos square theta minus sine square theta. I'm writing this in the form of writing cos 2 theta in the form of this because we have the values of cos theta and sine theta, plus 1 over 2, here we had theta because sine theta is equal to x. If we want the value of theta from here, we need to take the sine inverse of both sides, so it becomes theta is equal to sine inverse of x. So in the place of theta I have written sine inverse of x, and the third term was plus 1 over 4 natural log of this, here it was tan 2 theta plus secant 2 theta. So secant 2 theta can be written in the form of 1 over cos 2 theta, and tan 2 theta can be written in the form of sine 2 theta over cos 2 theta. We also need to replace this cos 2 theta just like this expression in the form of cos square theta minus sine square theta, and we also need to use the formula of sine 2 theta, which is simply 2 sine theta cos theta, so that we just need to put the values of sine theta and cos theta in this whole expression and calculate its value. So The first term was cos square theta minus sine square theta, and cos square theta is simply 1 minus x square, because cos theta was square root of 1 minus x square, and sine square theta is simply x square. So this becomes 1 minus x square plus 1 by 2 sine inverse of x plus 1 by 4 natural log of, I'm writing this cos 2 theta just like this term in the form of cos square theta minus sine square theta, and the formula for sine 2 theta is 2 sine theta cos theta, so over cos square theta minus sine square theta. So this first term becomes 1 by 4 natural log of 1 minus 2x square plus 1 over 2 sine inverse of x plus 1 over 4 natural log of the LCM. Both the fractions have the same denominator, cos square theta minus sine square theta, so this will be the LCM, and the numerators will be added, so 1 plus 2 sine theta cos theta. So these two terms are already in the form of x. We just now need to put the values of sine theta and cos theta in this term to get our final answer. So this will become 1 by 4 natural log of absolute of 1 minus 2x square plus 1 by 2 sine inverse of x plus 1 by 4 natural log of absolute of 1 plus 2x times square root of 1 minus x square, because we had 1 plus sine 2 theta, and sine 2 theta was 2 sine theta cos theta. Sine theta is simply x, and cos theta was square root of 1 minus x square. And in the numerator we had, in the denominator we had cos square theta minus sine square theta. Cos square theta is simply 1 minus x square, and sine square theta is x square. So the final answer will be 1 by 4 natural log of absolute of 1 minus 2x square plus 1 by 2 sine inverse of x plus 1 by 4 natural log of absolute of 1 plus 2x times square root of 1 minus x square over 1 minus 2x square plus the constant of integration.